Hello children, in today's class we will be solving the numericals based on current electricity. Children, in this chapter we have three units. In each and every unit we have related numericals. So in today's class especially we will be solving the numericals based on current electricity unit A numericals only. So next class we'll solve the numericals based on unit B, then finally we will solve the numericals based on unit C, so that what will happen, all numericals based on current electricity will be covered. Is it clear? Fine children. Now let us see the first numerical in this unit A exercise. Children, again I am repeating it is a exercise A based on numericals only. Children, here as per the event when we solve the numericals, you also can see the question on the screen. Okay, fine. So as per the question 1 children, here number of electrons are given, charge of electron is given, the time is 2 seconds. If these many electrons will pass in a 2 seconds, what is the current? Children, here we have a direct formula. I is equal to number of electrons into charge of each electron by time. So based on this, if you can substitute here 6.25 into 10 power 16 into 1.6 into 10 power minus 19 by 2. 2 ones are 2, 0.8. This is going to be 6.25 into 0.8 into 10 power minus 19 into 10 power 16. This is going to be 10 power minus 3. So this will become 5. 10 power minus 3 is nothing but milli. So 5 milliampere current. Is it clear? Fine. Come to the second numerical. Here the current is given. That means to have this much amount of current in this much time, that is in 1 second, how many number of electrons should flow, that they are asking. Fine children. So here as per this question here, we know that I is equal to NE by T. But let us make a N as a subject. It is, take this T this side. So I into T by E. So I is given 1.6. It is given milli. So milli means 10 power minus 3. 1.6 into 10 power minus 3 into 1 second by 1.6 into 10 power minus 19 coulombs. 1.6 cancel. In the numerator 10 power minus 3 their children. In the denominator 10 power minus 19. Take this to numerator. It will become 10 power 19. So as base are same, power should be added. Minus 3 plus 19, 16. So here N is equal to 10 power 16. Means what? These many electrons should flow. Okay, fine. Come to the third numerical. Your current is given 200 milliampere. Milli means 10 power minus 3. So 200 into 10 power minus 3 will become 0.2 ampere. Now they are asking us to calculate the potential difference based on Ohm's law. According to Ohm's law, V is equal to IR we have. So I value is given 0.2 into R value is 20. So this will become 0.2 into 20 will be 4 volt. Sorry, it's not ohm, right? So it is a 4 volt. 4 volt. That's it. Now come to the fourth numerical here. So here it is also same question based on the Ohm's law only. V is equal to, we know it is IR, but they are asking us to calculate the R value. So R is equal to will be V by I. So V is given 6. It will be 1.2. So multiply with the 10, divide with the 10. So this will become 60 by 12. So R is equal to 5 ohm. That's it. So come to the fifth question. Same, it's based on that only. It is V is equal to IR. V is equal to IR. V is equal to IR. So R is equal to V by I. So V value is 12 by 2. This is 6 ohm are given. Is it clear? Children, in some textbooks, as I am following actually 2 years back textbook, so in your textbook I think numbers might be different. Please just check that, but the method is this only. For example, instead of 200 milliampere, it might be 300 milliampere. Means there will become 0.3. 0.3 into 20 will be just 6 volt. So don't get confused. See, number might be different, but the concept, the method what are you following is same. Is it clear? Just copy these 5 numericals, then we will follow the 6th. Of course, we will be doing the 6th numerical. Just copy it. Hope it is done. Can I erase from here? Okay, let me start from here. So children, just these all numericals are formula based only, except one or two numericals, all are formula based. And so the 2 to 3 numericals are there which purely based on the concept. Okay, now fine. Now look at the 6th numerical. As per the numerical, it is given that calculate the current flowing through a wire of resistance. Okay, resistance is given, that is 5 ohm, and here potential difference is 3 ohm. So they are asking us to calculate the current. Same formula, that is V is equal to IR. So I is equal to it is V by R. So V is 3 children, R is 5. So I is equal to the 0.6 ampere. So such a simple numericals. Okay, now fine. Now if you can see the numerical 7, it is some data is given. Based on the data, they are asking us to draw the graph first of all, children. Okay, so VI graph they are asking. So let us make a VI graph. So here is, let us take I values here, V values. So I values are given. It is, let us say 0, 0.2, 0.4, 0.6, 0.8. It is in amperes, children. 0.8 and 1. So let us say it is 1.0 ampere. Okay, here it will be 0.5. This is 1.0 and here is 1.5 and it will be 2.0 and this is 2.5. That's it, up to 2.5 is given. So now children, so 0.2, 0.5, here you will get point here. 0.4 for 1, you will get here. 0.6 and 5, look at here. So you will get here, see 0.4, 0.5. Next 0.6 and 2, it will be here. So like this, we will be getting a point. Let us connect all these points. You will get a straight line passing through the origin. Okay, fine. So part B, they are asking us to find the current at 0.75. Children, 0.75 will come here, means exactly middle. Children, with this very clear that V is proportional to I, means it is varying in equal manner. So at a 0.5, the current is 0.2. At a 1, current is 0.4. So 0.75 is what actually in between, exactly. So in between, the current also will be in between. Means how much it will be in between means, so 0.3. So here the current will be 0.3. So 0.3 ampere. Just from the graph we have to see. Children, they are saying at 0.75 voltage, what is the current? So current is 0.3 amperes. So in between we have to see, that's it. And even they are asking us to find the resistance of the circuit. Resistance, children, resistance is nothing but what actually? Slope of the circuit. This slope of VI graph, it's very important. Look at here. So already we studied that slope of VI graph gives resistance. That is what? Resistance is equal to V by I. So any V value you can take and corresponding I value you should take. For example, here 1, 2, 3. So 4, 0. For example, for this one, so for 2.0, the corresponding current is 0.8. So this is 2 by 0.8. So this will become 20 by 8. So this is nothing but 4 5s are 4 2s are. So you are going to get a 2.5 ohm. That's it. Okay, now fine. This is numerical, what we can say, 7. Now come to the numerical 8, children. So as per the question here, try to understand here. So two wires of same length, but its radius is 1 mm. Let us say it is R1, and here another wire, its radius is 2 mm. Let us say it is R2. But both are made up of with the same material. Both are made up of with the same material. Now they are asking us to find the resistances and the specific heat, specific resistance also. Children, first of all, look at here. We know that R is proportional to 1 by A. Sorry, inversely, okay, proportional to 1 by A or inversely proportional to A. And we know that A is equal to pi R square. So R is also inversely proportional to the square of the radius of the wire. So it can be written as R1 by R2 is equal to R2 square by R1 square. Children, R2 is equal to how much? 2 mm. 2 millimeter means what? 10 power minus 3 whole square by R1 1 mm, that is 1 into 10 power minus 3 whole square. So this is going to be 4 into 10 power minus 6 by 1 into 10 power minus 6. These will get cancelled. So here R1 is to R2 is equal to 4 is to 1. So this is the first one. Now second one, they are asking us to find the ratio of specific resistance. Children, the ratio of specific resistance will be 1 is to 1. Why? What is the reason? Because specific resistance depends only on the nature. It does not depend on the dimension, that is, it doesn't depend on the length and area of cross section. Here it is given that both are made up of the same material. So hence specific resistance is same for both material. As specific resistance is same means what? We will get a 1 is to 1. Clear? Just copy it. So this is the 8th numerical. Fine, children. Now hope it is copied. Fine. Now let us move to the numerical 9. Simple numerical, children. Don't make it complicate. Don't make it complicate. So it is 9th one. So a given wire of resistance 1 ohm is stretched to double to its length. Means, for example, children, let us say it's a wire. Okay, no, fine. Let us say this is a wire. Its resistance is given 1 ohm. Let us say R1, let us say. Its length is L, let us say that, children. Now they are saying that this wire is stretched. Children, this is specially stretching case. Very, 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 very important. Stretching case. I want you to note down the stretching case. So whenever you can stretch the wire, children, its length increases. So its length increases, area of cross section decreases, but volume remains constant. Volume remains constant. Very, very, very important. Look at here. We know that R is equal to rho into L by A. So let us multiply with L, divide with L. Okay, nothing is wrong because this will get cancelled. Fine. Can we write like this? Rho into L square by area of cross section into length. It will be volume. But during stretching case, volume remains constant. And as we are stretching means what? We are not changing the material. So specific resistance also constant. Specific resistance also constant. Try to understand. Means here two quantities are constant. What is the first quantity here? Volume. Children, during stretching case, volume is a constant, resistivity is a constant. Then R is proportional to the L square. Now this can be written as R1 by R2 is equal to L1 square by L2 square. Now they said that they are stretching to double to its length. Means what? New length, it is becoming a 2L. Then what is the resistance of this wire? Okay, now substitute here. R1 is 1, R2 has to be calculated. L1 is L square only, 2L is, L2 is 2L whole square. This will be L square by 4L square. L square cancel. This will be 1 by 4. So 1 by R2 is equal to 1 by 4. Then R2 is equal to, it will be 4 ohm. That's it, children. Is it clear? Just concept, children. So during a stretching case, volume remains constant. So only during stretching case only this formula is applicable. Don't get confused. So already we know that R is proportional to L. Okay now. But how can we write? Yes, only during stretching case only we are writing. Because during the stretching, what happens? Volume remains constant. So we have to write a resistance in terms of volume. Then we will get like this formula. Like this. Okay now? Just copy that. Yes. Now we will move to the 9th numerical is over. Just move to the 10th numerical. 10th numerical. 10th one. So as per the question, children, a wire of resistance, okay, wire, let us say its resistance is 3 ohm and the length is given 10 centimeters. Fine. This wire is stretched. Okay. So the same wire is stretched like this, it seems. So L, then the length became 30 centimeters. Then what will be the new resistance they are asking? Children, this is also stretching case only. This is also stretching case. This is also stretching case. So whenever wire is stretched, volume remains constant and R is proportional to the L square. Then it can be written as R1 by R2 is equal to L1 square by it is L2 square. So R1 is 3, R2 has to be calculated. L1 square means 10 square, it will be 100. L2 square, 30 square, it will be 900. So zeros cancel. Do cross multiplication. R2 is equal to 9 into 3. That is 27 ohm. 27 ohm. Clear? Children, these two numericals are based on stretching case only. Just copy it. Fine, children. Now we will see the 11th numerical. Children, again 11th numerical is a bit special one it is. So numerical 11, it is special. It is given that a wire of ohm resistance, okay, wire of resistance 9 ohm, okay, having a length is 30 centimeters, okay. Now it is tripled on itself. Then what is the new resistance? Tripled on itself. Children, here this is a special case, as I told you that. Just let us have some discussion about it. First of all, let us try to understand what is doubled on itself. Doubled on itself is what? Tripled on itself is what? Some students are thinking that doubled on itself means they are thinking that length is doubled. No, it's not that. Wrong it is. Try to understand. Stretching is different. Stretching means length increases. But doubled on itself, look at it. For example, like this, it is given in a question. Doubled on itself. Doubled on itself. For example, here one wire is there. Its resistance is R and its length is L. Okay, na? Doubled on itself means it's exactly making into two pieces, and keeping like this, one piece over the other. This is called doubled on itself. Its area of cross section A. Now here what is happening here? Area of cross section is becoming 2A and new length is become L by 2. Half is becoming. So this is new area of cross section. It is new length. Try to understand it. Very. So doubled on itself means what here? Just exactly make into two pieces, keeping one above the other, such that area of cross section will be doubled, length will become half. For suppose here, for this resistance is rho into L by A. Then for this resistance is R dash, let us say, that is rho will be same because we are not changing the material. Okay. In the place of length, what we have to take here? L by 2. Okay. In the place of area of cross section, we should take a 2A. So this will become, this 2 will come to the numerator. It is 1 by 4 into rho L by A. So this rho L by A is what actually? Resistance. So here R dash is equal to 1/4 of R. 1/4 of R. Which means what? When any wire is doubled on itself, then the new resistance, what will happen? 1/4. It will become 1/4 of its original value. Then tripled means, you can guess. Tripled means what, children? Yes. So here for example, this you should make into 3 pieces. Okay, na? Then here L dash will become L by 3 and A dash will become 3A. Why? Because these 3 pieces we have to keep one above the other like this. 2, 3. So this area of cross section will be 3A and this new length will be L by 3. When you apply the same concept, so you get here R dash is equal to 1 by 9 it will become, because tripled right, 1 by 9 it is a R. So this formula we have to use, children. So where doubled on itself means use this formula, tripled on itself means this formula, quadrupled on itself means yes, R dash is equal to 1 by 16th of R, quadrupled. So now as per this question here, yes, as it is a tripled, so R value is given, so it is 1 by 9 into 9. Both will get cancelled, so new resistance will be 1 ohm. That's it. Concept, children, the just previous two numericals and this numerical. So these are not a direct formula based. Just we have to use the concept. Then we will get one new formula. In that we have to substitute so that we will get an answer. Clear? Just copy it. Clear? Shall we move? Okay. 3, 2, 1. Yeah. Now So in this numerical, what is given? Numerical 12. Numerical, as per the question, children. So specific resistance is given, that is 1.7 into 10 power minus 8 ohm, and the radius is given 1 mm. So this can be written as 1 into 10 power minus 3 meters, and resistance is given 1 ohm. Now they are asking us to find the length of that conductor. Children, here we know that R is equal to rho into L by A. So we can rewrite the formula to make length as a subject. So L is equal to R into A by rho. Fine. But A value is not given. No problem. R is given, right? Because we know that A is equal to pi R square. That is 3.14 into 1 into 10 power minus 3 whole square meter square. This value we can substitute. Now let us substitute. R is given 1, A is 3.14 into this will become 1 into 10 power minus 6 by rho value is how much? 1.7 into 10 power minus 8. Now look at here, this will be 3.14 by 1.7 into 10 power minus 6. This will be come to numerator. This will be 10 power just 8. So this is 3.14 by 7. So this we can write like this, right? So 17 by 10. This 10 will go to the numerator. Okay, na? Fine. Or else simple manner, how can we write here? 31.4 by 17 into 10 power 2. So this is nothing but 3140 by 17. So if we can simplify this, we'll get 184.7 meters. This is the length of the given conductor. Length of the given conductor. Just here simplification ma. Just we should have some patience. Then we'll get the solution. What is it? Fine, children. Now here is last numerical. That is 13th numerical. So it is the last numerical. It is given that, children, a filament bulb takes here 100 milliampere current. So this can be written as 100 into 10 power minus 3. This is nothing but 0.1 ampere. That's fine. When a potential difference 0.2 volt is applied actually, then they are asking us to find the resistance. Okay, it's a case 1. When the potential difference across it becomes 1 volt, okay, when potential difference is 1 volt, how much current is drawn? They are saying that here 400 milliampere, that is 400 into 10 power minus 3 ampere, which means what? 0.4 ampere current is drawn for this much voltage. Now thing is that calculate the resistance of a filament in each case and account for the difference. Okay, fine. So in both cases we have to use V is equal to IR formula only. So R is equal to V by I. So V is given here 0.2 by 0.1. So this is nothing but the 2 ohm. Okay, in the first case. In the second case, it is V is equal to same formula, it is IR only. So R is equal to V by I. So V value is 1 and this is 0.4 at 0.4 into 10 multiply with the 10. This will be 10 by 4. So 10 by 4 is nothing but what it's a 2.5 ohm. So which means what actually in this second case, let us say the case 1, the case 2. I think in case 2 bulb is glowing actually. It's very important that here bulb is glowing. Children, already we know that when the bulb is glowing, its temperature is increased. When the temperature increase, obviously what happens? Resistance also increased. Okay, children, fine. So these are the numericals based on the current electricity unit A. And actually numericals based on unit B are most more challenging. Why? Because they are conceptual oriented and they are lengthy. So to solve that, numericals based on unit B, so you should have a concept, at the same time you should have a patience to do it, children. In fact, you should have patience to listen also, because they are a bit lengthy type it is, but they are really beautiful numericals. So there are almost 31 numericals are there. So if I can make a 31 numericals in a one video, so it will go more than 1 hour actually, definitely. So we'll try to do it. So anyhow, today just we have completed this session as a numericals based on exercise A, that is 8A. So whatever the numericals which we have in unit B, just we'll try to make it two parts, so that what will happen for you also, you feel bit comfortable when you are watching the video. Okay children, fine. So again I'm telling you, just these numericals, not like just listening more. Just take a pen and paper, just have a practice more number of times till you get a confident that you will do it in exam. Okay children, thank you so much, all the very best.